Hello, everybody. Can you confirm if you can hear me now? Awesome, fantastic. I see a lot of yeses popping onto the screen. Well, hello, everyone, and welcome to the first Python workshop. This series is going to be presented to you by the University of Toronto IEEE student branch, your own very student branch of Institute for Electrical and Engineers of the University of Toronto. And we also have the CSSU here today helping us out. And all of these workshops would be a partnership with the CSSU, the Computer Science Student Union at the University of Toronto as well. My name is Mushtaba, and today we are here with 6 others of our members of the IEEE student branch to help you guys to learn some of the basics of the Python language. So I'm going to pass it on to my friend Shui right now to start the workshop, and we should be starting very soon.
Okay. Moji, can you hear me?
Yes, Shui, we can hear you loud and clear.
Okay, sorry. Yeah, some chat box was popping off. So yeah, quick introduction to Python itself. So it's a very popular programming language currently used in industry. It has a very easy syntax to learn. So basically, it's like conversational English. When you read the syntax, you can kind of understand what the program's trying to do already. It's also very versatile, can be used for cross-platform, so you can program on any type of operating system and it should be fine. It can be used for many different things, such as connecting databases, the backend for websites, utilize different libraries for like visualization, such as like OpenCV, and also used for machine learning and etc. Next slide, please.
So for this workshop, we instructed you guys to download Python and VS Code beforehand. If you haven't, that's okay. You can use your own text editor to code in Python, or you can also use an online text editor as well. I will link one into chat right now in case you don't have any downloaded. This will allow you to code in Python so that you can code alongside the presenter as they're sharing their screen and coding as well. And yeah, so I'll take over this screen share, and I will show you how to set up VS Code and how to actually start a new file so that you can code in VS Code. Okay, so can everyone see my screen now? Okay, cool. So basically what you want to do when we're using VS Code, you want to create a folder on your desktop. So like as your if you are choosing to use VS Code, please follow along with these instructions so that you are ready to go when our presenter starts coding in Python. If you're using your own text editor, you can take this time. You can use the next 5 minutes to get ready on your own. Or if you're using the online compiler, you can just use this time to get familiar. So if you're using VS Code, Visual Studio Code, create a new folder, and you can name this folder anything you want. I'm just going to call it Python intro. Does it really matter? Now what you want to do is you want to open up VS Code on your computer. And when you open up VS Code, it should look something along the lines of sorry, my laptop is going a bit slow, but once you do open up VS Code, what we're going to do is we're going to open up the folder that you just created on your desktop in VS Code. So as you can see here, you can go to File and you can do Open Folder. And then once you click Open Folder, you want to go to the folder that you just created. So mine was on desktop. I created mine called Intro to Python, or Python Intro. So I'm just going to click on the Python Intro folder, select folder, and it will open this folder in VS Code. So as you can see now on this left-hand side, our Python Intro folder is open. So now we can create a new file inside this folder to start coding. So if we want to create a new file, we can click this new file icon. It's the first of the 4 icons. And you can give any name, you can give the file any name. So like hello world, whatever, intro, you can name it whatever. But do remember at the end of the file, you have to write the .py extension so that VS Code understands that this is a Python file and that you intend to code in Python. So as you can see, once I add the .py file extension, it adds the Python icon as well. So then once you press enter, it will create that folder, it will create the file in this folder, and you will have access to the text editor and to the file, and you can type your code in here. So I'm just gonna do like just a basic snippet of like just print hello, just to make sure that everything is working. As you're following along with the presenter, what you want to do whenever you want to run code, like once you've written out the code here, whenever you want to run it, what you want to do is you want to do right click, and it will open up this, and you can click on Run Python File in Terminal. And so what this will do is it will pop up a terminal at the bottom, and it will run this file in it so that you can actually see if you printed out something or if the result of your coding. If you're getting a pop-up here, linter pylint is not installed, don't worry, we're going to take care of that in just a few minutes. But as you can see now, the terminal has opened and it will now run the program that like the print program. So if everyone can please like follow along and try printing out hello in their own IDE or in VS Code as well, just to make sure that they are getting the hello properly so that it does work. If you do have any problems, if you're having problems getting hello to appear on your computer or in the terminal, please put your questions in the chat box, and our mentors will help walk you through the process of fixing the problem. So yeah, so just before we do get to the actual coding question, actually I see there is a couple of questions going on right now, so we'll be using like a couple of minutes to go over these problems and these issues, just so that people don't fall behind when it comes time to the actual workshop. So for the next couple of minutes, we're just going to be debugging issues. If you have any, just put them in the chat. But if everything else is working fine, just sit tight and we will start the actual coding soon, very soon. For those of you who are using VS Code and do get the hello to work, we do need to install just one more thing in VS Code. So what you want to do is you want to click the settings. You want to click command palette. And you want to type in run linting and click run linting. So when you click that command, it will probably pop up this notification, linter pylint is not installed. So what pylint is, it basically checks over your code to make sure that it fits within the Python format. So let's say I have this print statement here. If I didn't have these brackets, the pilot would give me an error and say that this is not proper Python code, and so you need to fix your code. So it basically makes sure that you're actually coding within the coding, like actual Python code. So what you want to do with this notification, you can just press install, and it will automatically, in your terminal, it will automatically install Pylint for you, so that whenever you're writing your code, Pylint will automatically check it for errors or for any other like faults that may happen with your code. And it may take 30-ish seconds to run it, but as you can see, like it will download all of Pylint and it will say like installation complete. And as you can see, successfully installed Pylint. So now it is installed. So now, like, let's say I was to remove these brackets and I was trying to run Python file. You can see it was, it shows you that, you do have a syntax error. And it also like highlights it for you. And you can see Pylint syntax error, missing parentheses in call to print, right? And then it also gives you a sort of a suggestion, like, did you mean print with the brackets? So you can just add the brackets back and it will be fixed now if you try running it again. So we will be taking just 2 to 3 minutes now, just as a break, just to finish any installation issues or any issues trying to get it to work. And we will start the actual coding introduction in just a few minutes.
Thank you very much, Amanish. I'm just going to add some housekeeping rules that we're going to have through the next 2 hours that we'll be together, guys. If you see yourself kind of in a situation that you can't solve your problem yourself, or you can't follow along what's going on with the speaker, please tell us in the chat and we'll try to assign you to a breakout room with one of our mentors here, and they will help you solve your issue and get back to the pace with the rest of the people. And right now we have Margaret, Nick, and Birva, and I apologize for pronouncing your name wrong. You should be able to go to the breakout room. If you have it figured out, then that's fantastic. Okay, good. And if you haven't, do join the breakout room and let us know what's going on, and we'll keep you updated with any other information. Also, please keep your microphones muted at all times unless permitted to speak. And if you do need to speak, please use it. If there's an issue, we want to fix it in the chat. If not, we'll try to see if there's another way we can fix it. And since the course is going fast, guys, there might be some times that you find yourself this session. We'll be sharing with you guys the recording of the session, and you can go back and look at what has been done and then follow along. There's also going to be some slides shared with you guys if they haven't been shared already, that act as a complementary to what will be shared with you guys today. If you have any other questions, feel free to reach us in the chat.
Just to reiterate how you can run code in VS Code, you just right-click on anywhere in your file screen here. You can right-click. Let me just remove this terminal so you can actually see it properly. So you can right-click anywhere in your file, and you can click Run Python File in Terminal. And so what this will do is it will pop up a terminal, and it will call the Python executable, and then it will run your hello world.py file. And as you can see, my code line was a print line, so it printed out hello in the terminal. And I see there are a few there is a few people who are unable to do the find the run linting command. Before this workshop, I think we linked you to a video that shows you how to download the Python extension, but I'll just run through that quickly right now while we are waiting for everyone else to finish. So right now, you are in the Explorer tab of VS Code. So if you go to the last option in this on the left side, the Extensions tab, you click it, and then you can search for, if you search for Python, just make this a little bit bigger. If you search for Python, the first result will be the Python extension with the 24.7 million downloads. If you click on it, there should be a download, an install button here. If you click the install button, it should take a minute or so to install Python, and then try the run linting command again, and it should pop up now. If you are still unable to figure it out, I will link in chat again an online debugger, an online IDE for an online Python compiler. That way you can still learn it, and then later on you can go through the steps of downloading VS Code and using it on your laptop or computer after the workshop is over. The reason we decide to show you VS Code is because a lot of companies and industries use VS Code when communicating in group projects or when they're completing tasks. VS Code has that versatility and has many extensions to help you basically make the most of your, it's a really good text editor, basically.
Hello, can you guys hear me? All right, great. So my name is Chan. I'm a third-year engineering science student, and I'll be kind of running through the Python workshop for today. I'm going to share my screen real quick. So, okay. That's that. And so this is basically kind of, as Moji and Han and Shui has said, this is kind of like an overview, a pretty quick run through of, Python, obviously not in like as much detail as, maybe like a course that you guys might take in the future might cover it, but, we'll try to get through all the basics. And again, this is a multi-part workshop, so there will be other sessions for, more advanced topics later on. And so let's get right into it. So let's start with input and outputs in Python. And so first of all, when you run a Python file, obviously there's a lot of things you can run, like functions and print statements and whatnot. But let's say you don't want to run something. Let's say you just want to comment stuff out. Then a single hashtag, or multiple hashtags, but single one is more than enough just to comment out a line, and you use this for single lines. Whereas these triple quotations you can use to comment out multiple lines. And this just allows you to maybe explain your code or explain sections of your code better as people, because other people might also go through the files you create. So to start off, Python has a print function that allows you to display basically any text at the console, among other things, including numbers and integers, and we'll get into those later. But to start off with, if we uncomment this line, you see print, and here in quotations, string, I'm Python, nice to meet you. If we run this, we should get this response in the terminal. I'm Python, nice to meet you. So, and also if we comment it out and we decide to run this file, then we won't get anything because it's in the comments. And also a little thing to keep note of, I guess, is by default, the print function will also print out a new line at the end. That's why you see this like skip of a new line. If you want to change this, you can by specifying it with the end kind of argument and here. So right now it's just hello world but no exclamation mark. But with the end added here, if you run it, it should also have an exclamation mark. So just another extra thing if you want to add stuff to the end of your print statements. So for our first activity, we'll give you 2 minutes for this. In your own consoles, try to print out the phrase, my name is blank, followed by your name, and hello into your console. And this should take around 2 minutes to complete. I guess give some indication in the chat if you've successfully finished it, I guess. Oh, and yeah, we will be sharing the answers to these activities after each of them in this file, the workshop 1 answers, and try not to peek at the other answers while we're at it. That'd be great. Okay, nice. Okay. Okay, so let's go to the answer for this activity. And okay, give me a sec. Sorry about that, guys. So here's an example of how you can go about doing this. Just put in print, and my name is Chan. Hello. If we run it, look at that. It's a miracle. And then moving on. So there's a simple way to get input data from the console. So actually getting data from the user, from the console as you're running a script. And that's through this little bit of syntax input. And then you don't have to put anything here. If you just put input, it'll be like a blank console, and then you just like type something in to like input it. But having some sort of message, to indicate what kind of input you want, like enter some number, is very helpful for other users that aren't you. So I'll give you an example, and this should, in theory, print out you entered plus whatever input you put into this variable. So on the console, just enter some number, and we can type in 5, for example, and this prints you entered 5, which is true. And this is actually, you enter a number, but it comes out as a string, but we'll get into that very quickly. So keep that in mind. And actually, we're getting into it right now with the introduction of data types and variables. So in Python, obviously, there's like a couple different types of variables and data types. So an integer is just like a number, but without decimal points. So 0, -1, 1, 2, 3, etc. And it looks like I equals 1. You can declare it like this. A string is any combination of characters inside these quotation marks. And one thing that you do have to note is kind of doing operations in between these data types will not work usually. Like you can't add an integer to a string. But there are some ways around it that we will get into later on. But yeah, so this, for all intents and purposes, think of it as like like words for now, I guess. They're in quotations and they're like words. And you can put numbers into strings as well. Bracket, like quotation mark 2 is also a string, as we saw in the above example with the input. And a Boolean is your classic true or false. And you can assign a variable to equal these Booleans, like true or false. And we can get into some more Boolean operations later. But if you've seen any kind of like discrete math or any kind of course before, you might have seen that before as well. And floats are just like your decimal numbers, like pi, for example. Oh, close to pi, anyways. And moving on, next is operators. So you can assign, as we saw before, variables to different values, and you can do them in like a multi kind of like step fashion. So x, y, first and second are assigned 4, 10, the string e and the string hello respectively. And this is kind of a use of the multi-line comment tool, but this is kind of what values they would be assigned if we were to run it in terminal. So let's run that quickly. And just kind of like prove it, let's say if we print out first, we should get the letter E because it's going to assign this third value here. Let me get out E. That's great. And this is kind of going into the actual operators that are available in Python. And you may have seen this before in like other like maybe math courses or other programming courses. We've seen it in high school, but if not, don't worry, we'll get into it. So and basically compares, you know, if both statements inside are true. So let's check here. So we know that x is equal to 4, and keep that in mind going forward. Now we'll print is x less than 5 and is x less than 10. So is 4 less than 5 and is it less than 10? Hopefully I don't need to tell you the actual answer to that one, but yeah, it's true. 4 is indeed both less than 5 and less than 10. And this is the or. So it returns true if only one of the statements in the conditionals are true. So if 4 is less than 5 or 4 is less than 4, then it will print true. If not, it will print false. So in this case, one of these conditionals is obviously met. 4 is definitely less than 5. Let's double check that. That's true. And let's say we change it to, you know, like 3, then it'll be false because, you know, 4 is greater than 3. And for the not, it's actually the reverse of whatever we saw before. So, you know, print true if it's not the case that 4 is less than 5 and less than 10. So basically it just takes this and flips it. So we should get false from this one as well. And is. So this is only true if they're the same object. So is, so, you know, again, kind of like where the whole Python kind of, you know, reads like English bit, you know, is 4 10? Because, you know, y was assigned to the value of 10. And this is false. 4 is actually not 10. And is not returns true. Both variables are not the same object. So again, you know, reading it again, like, you know, if x is not y, then return true. So if 4 is not 10, then return true. And hopefully it's true. 4 is not 10. And some other ones. So double equal. Do not confuse double equal with a single equal sign. That's a pretty common mistake. But like an equal sign is, you know, you assigning the value on the left to that of the right. But a double equal sign returns true only if both sides are equal. So if 4 is equal to 4, then return true, which is, you know, that's obviously the case. So yeah. And this is the greater than or equal sign. So this returns true if the first variable is greater than or equal to the second variable. So remember, x is 4 and y is 10. And we'll print true if x is greater than or equal to y, or to 10. And 4 is not greater than or equal to 10. So, you know, turns false. And here, it's less than or equal. So basically, this will print true if the left side is less than or equal to 10. So is 4 less than or equal to 10? And that is the case, yeah. It's good to confirm some stuff. And again, to kind of like to refresh, you know, first is equal to the string E or the character E, and then second is equal to hello. So these next ones will, for in is it returns true if a sequence with a specified value is present in the object. So basically, is E in the word hello? Like that's what we're asking when we're doing this statement. First, we're gonna print first in second, because first has been assigned to the, you know, value E as a string, and second to hello. So this kind of so this print will give us the answer to this print. These are the exact same commands as far as this program is concerned. So is E in the word hello? And hopefully we get true, and we do, because, you know, E is in the word hello. And last but not least, not in returns true if a sequence with a specified value is not present in the object. So, you know, if E is not in the word hello, for example, because, you know, first is E and second is hello here, which will give us false, because E actually is in hello. And let's see. Oh, if you guys have questions, you know, do feel free to, you know, type in the chat. We do have a lot of moderators on hand to hopefully help you out with some of these questions. But moving on with Booleans. So this is kind of going back to the whole like true false statements that we saw before. So for people that are new to Booleans, it might be a bit confusing, but a good way to think about it is, you know, especially with these operations like and or, is if you print, true and false, like it's only true if both of these sides are true. Like, you can't be true and false at the same time. And the only way this holds true is if, both sides are true. And it's a bit like convoluted right now, but hopefully with some later examples, it will become a bit more like intuitive, or if not now, definitely later on. But for all intents and purposes, for Booleans, if you want this and statement to be true, both sides of these have to be true. So here we'll get false. Whereas for here, we'll print true or false. So if one of these is true, then it prints true. So this should print, oops, sorry. So this should print true, and does. And then, so basically another way to look at this is that, Booleans are assigned numerical values. Basically false is equal to 0 and true is any other number that is not 0. So a good way to check this out for yourself is you can test, is 0 equal to false? That's what this double equal sign is. It's not assigning any values. It's checking if the left side is equal to that of the right side. So we're printing if 0 is equal to false. And in this case, we'll get true. 0 is equal to false. Whereas, basically for every other combination, we'll get that it's true, because if 1 is equal to true or 2 is equal to true, any value that is not 0 is equal to true is true. Wait a sec. True. Oh, sorry, never mind. So 1 is true then. Sorry about that, guys. And here we'll get, print if -5 is not equal to false. So, -5 is not equal to false. So that's true because it is. So. And I guess just moving on, there are some more operators that we can learn in Python. So there's addition, just like classic. So we are assigning x and y to be the values 10 and 2 respectively. And we want to print out the addition of x plus y, which is 12. And then we'll also do x is equal to x plus 3. Or another way to write this, actually, this is a good thing to point out. Another way to write x is equal to x plus 3 is x plus equal 3. Like this, like these two lines are exactly the same. And there's like a nice kind of like shortcut that you can use in the future. Like if you have some repetitive tasks, if you want to like keep adding to like a variable, like some specific value, instead of doing like, let's say you call it I, instead of doing like I equals I plus n, or like I equals I plus 3, you can just do I plus equal and then whatever you want to add to it. So this is a nice kind of shorthand notation that we'll see a lot more going forward. Let's just double check. We do get 12. And then now, since now we get 12, and then x is equal to x plus 3. So 10 plus 3 is 13. So that's what we get. And we can also do subtraction. So again, with the same values, x is 10 and y is 12, y is 2. We can print out x minus y, which is 10 minus 2. And that should give us 8. And then we can also print out x is equal to x minus 3, or again, same shorthand notation is x minus equal 3. And that should also give us 7. And it does. It's good to know. And there's also multiplication. So again, same values, but now we're doing 10 times 2, or x times y. That should give us 20, and then 10 times 3, or again, same notation, same shorthand, asterisk, star equal 3. These two lines will be the exact same thing. And again, 20 and 30. And then there's division. So there's x and y equal to 24 and 2. And we can print the result of 24 divided by 2, or in this case, x divided by y. Another way to write, and then we can also do x is equal to x divided by 3. This is actually not the same, but let's just look at the output of this. Okay, 12 and then 8. Oh, and do note that when we divide it, there are like these decimal places. We will we'll get into like other operations of those later on, but yeah. And this is called modulus. You may have heard of this from like previous math courses. If not, that's fine. I know I did it in first year. But modulus is basically just returning the remainder of the equation. So let's say you do like, for this example, like you're dividing 10 by 6, then you have 1 and then you have 6 remaining. So it only gives you the actual like remainder. So let's uncomment these two up first. So it gives you 4 because 6 goes into 10 one time and there's 4 left over. And as for this is the same as x is equal to x mod 3. So 10 divided by 3 and then whatever remainder is left. So it should be 1. If I remember division correctly. Yeah, it's 1. So this simple modulus is just basically, a way to return the remainder of whatever division you may do. And for exponentials, it's pretty simple. It's just a double star. So, 2 multiplication symbols for all intents and purposes. And again, this also has an equivalent where you can do x star star 2 for x to the power of 2, or just x star star equal 2, the same result. So here you can print out 5 to the power of 2, which is 25. And here we can also print x is equal to x to the power of 2 as well. It's 25 in both cases. And again, a recording of this will be sent out, so don't worry if you can't quite catch up, but don't worry too much about that. And then for floor division, this is kind of like the opposite of modulus, where modulus gives you the remainder of whatever division equation you go under. The floor division removes the remainder and only gives you, a division. So, for example, 10 divided by 6 is 1 with the remainder of 4. So floor division will only give you a 1. So let's kind of highlight that. Yep. So for the first one, x, floor division by y, which is 10 floor division by 3 is 3 goes into 10 3 times with 1 remainder. This kind of eats out the remainder, only leaves 3. And for this one, x is equal to x floor division by 3 here with this expression, which is kind of the same. And again, 3, with the remainder of 1 being ignored and omitted. So these are kind of like the operations you can do onto variables for Python. And kind of moving forward, we're going to talk about variable casting. So recall before that, we talked about how there's different types of variables like integers, floats, strings, whatnot. And you can actually change one into the other and vice versa. So here's an example. So B right now is assigned as not the number 10, but you see these quotations, it's like the string 10. So think of it as like a word really. And let's try to print out, B is equal to, let's print out B divided by 4. And right now this will give a type error. Because, you can't. Like, how can you divide a word by a number? Makes no sense. Unless you're in some courses. And if not, though, we try print integer B divided by 4. So this will cast B as an integer. So, this is a number 10 in like a word form. And this integer will take whatever B is and turn it into an integer. Now, obviously, this won't work if, there's an actual word. Like if you assign B is equal to, like the word like truck, like int B makes absolutely no sense. But in this case, since it is like a number here, and it does. So on this, and we get 2.5. Remember, this isn't like floor division, so it's not just going to give us a 2. This is like actual division, so this will give us 2.5. And you can also use these casted variables to add to numbers or actually, string up strings together when you add them. So forgive the pedantic language, I'll get into the explanation. So basically, here we have A is equal to the word 8 or the string 8, and B is equal to the actual integer 8. So if we print A plus string B, so the word 8 plus the word 8, we should get 88 as a word. So we get 88. But if you do the same, but instead we cast the string A as an integer, 8, then we get 16. So if you do additions between strings or words, you kind of just like, combine them together into a single word. Whereas, for integers, it's what you expect. You're adding two numbers together, you're subtracting or whatnot. So, and we're gonna do a quick activity for about 5 minutes, and I'll try to keep these examples, here so you can kind of reference them. And this might take a bit longer than the last one, but try to create a string variable. So like, a here, like with quotation marks, and then cast it into like, so create a string variable var that's equal to 100 as a word, and then cast it as an integer. So transform it into an integer, and then multiply that resulting cast by 5 and print out that result. And everything you need for that should be here. So just try to get through this, activity within the next 5 minutes. Okay. See. And sorry guys, it's kind of hard to read chat while I'm doing this, but definitely I will try to slow down going forward. But hopefully everything, this activity should be kind of like isolated to this section only. So hopefully you can get through this, through these notes alone.
Yeah, and if there's anybody who's hopelessly lost right now, please do let me know via chat, and I'll send you to a breakout room with one of our mentors. Daniel, you need help? Okay. Excellent, thank you.
Yeah, we could probably extend the activity like duration just by a bit if you are a bit ahead of schedule, just like accommodate. But yeah. Yeah, sorry about that. I should have probably tried to like multitask with chat open. But we'll definitely try to keep it slow going ahead, especially considering that this material does get not more complex, but a bit more involved as we go ahead. So I'll definitely try to like slow it down. I'll try to keep chat open actually. If the Twitch streamers can do it, then hopefully so can I. But yeah, again, like, like the recording will be sent out. There'll be like, extra kind of like, materials on hand for this. And, this is only like a 2-hour session. You're going to have courses dedicated to this kind of stuff later on. So, this is kind of like an overview of what you might, expect to see later on. Oh, yeah, sure. Let's go back to the print true and false thing. Not gonna lie, like this, like looking at it standalone kind of confuses me too, just a little bit, because it's like, you usually use it in conjunction with other things, like like loops, for example, that will actually kind of like get into going forward. But like as of right now, it's kind of like I don't know if you've done like binary operations maybe, but with like the whole like ones and zeros, like like 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, and 0 and 0 is like, yeah, that's not a great explanation, is it? As day and night, kind of. For this specific example, like, can it be day and night at the same time? Like, Like, no, it's always one or the other. Sarah's question. I think she might be referring to line 191 here with the 88 and 16. If that's okay. Well, it's not really multiplying. 8 times 8 isn't really 88, but what's happening here is kind of like, so right now, A is the word 8, right? Or like the string 8. And B is the actual number 8. And you can't really like add a string to an integer, as we kind of, mentioned before. And so what we're doing here though, is we're printing A as in like, the word 8, and B as in the word 8 now, because we're, transforming it into a string. So what happens is you do, so actually here's, let's do some impromptu stuff, I guess. Like, if this number thing confuses you, like, let's see what happens if you just print 2 like words together, right? So let's print hi plus how are you? So if we print this with a combination of the two, so hi, how are you? These are like 2 strings that are kind of like added together. So no, let's replace this with 8 and 8, which is exactly what this above line 191 is doing. So we do this because it's transforming the number 8 into a string 8, then you'll get 88. Because again, you're combining 2 things. Before, how it's like hi and how are you combined in this manner, these are just 2 words that you can combine. Whereas for this line, you're not combining 2 words, you're actually adding 2 integers. Like you're adding the integer A that's been transformed into 8, and then B, which is already 8. So if you run this, you get no, I'm lying. No, we gotta uncomment this out, sorry. Be sure to uncomment crucial variables that are assigned. But yeah, if you do this, then we get 16. So okay, yeah, glad to miss it. Oh, I should have chat up. What was I thinking? Okay, no, that's fine. Let's see. Okay, okay. So basically, for this example, just think of it like for if you have and, both conditions on either side have to be true. Anything else, then it's false. Whereas for the second one, like true or false, like it's checking if either one of these, like the first one or the second one, is true. And the first one is true in this case, so you get true. If you did true or true, then you also get true. Because this is just checking, is this first variable or is the second one true? And it is a bit confusing, standalone, definitely. And that's why we kind of use these Booleans in conjunction with stuff that we'll get into later. So like, if you don't get it now, like don't get too hung up on it. Honestly, I can't really think of like a decent example for this right now. So like, we will try to get into it later on with some other ways of implementing these things. So print is E and hello, and is E and hello both show syntax errors? Okay. So this is kind of where okay, I think it worked. Okay, sure. I mean, we did have a 5-minute break scheduled for after this activity, but if you guys want to keep asking questions, like, that's also cool. You can keep that going for maybe like 5 to 10 more minutes. I'll get the answer to this activity actually right now. Again, there's a lot of ways to get the right answer for coding, but there are faster ways of getting it for sure. But this is one example. So we first declare a variable, var, as a string 100, and we cast it as an integer. So we do int var, and this will just turn the 100 from the string into the actual number or integer 100. And we multiply it by 5, so we just multiply that by the integer 5, and we print out the result. Hopefully we get 500, which we do. Okay. Ah, thanks, Chief. Let's see. If anyone else has any questions, keep them coming. We have like 4-ish minutes left of break, or if not, we can try to get a head start on the next section. Okay, that's good. Does anyone have any, pressing objections to going forward, or are we still kind of on our break? Good to go. Oh, my hero. Okay. Well, I don't think it was a one-man democracy, but let's see. But 2 is different, isn't it? All right, never mind. We'll give them a minute. Oh, wait. Yeah, you're right. There probably are people still on break. Okay, see how many people raise your hand. Wait. Oh, I'm negative IQing it. Okay. All right, y'all can chill, all right? Like, oh, okay. Listen, I've had 9 hours of lecture today, all right? Y'all don't understand the struggle. Actually, yeah, you probably will soon, but such an idiot. Okay. Tell us the secrets of passing first year Ensign. First year Ensign. Oh, it's a fun time. I don't know, bro. Civ 102, bit of a sacrificial course. Yeah. Okay, well, if people are back, show word cloud. Pardon. Sorry, guys, 1 sec. Gotcha. All right, so bit of a tangent here. So the word cloud y'all kind of filled out before. We can kind of display that here. So it seems that, oh my God, there's a lot of Ensigns here. A lot of Ensign 2T4s, which makes sense. You guys do have that. We all had that Python coding course, I believe, in first semester still. So, but it's good to see there's a good chunk of people from the humanities here. Civ 2T4, that's nice. Yeah, you see 2T4, that makes sense. Okay, PY, gotcha. And this is for your, I'm assuming this is kind of like if you have any coding experience before. A lot of Python, a lot of Java, basic, my God, okay. MATLAB, beginner. Hey, don't worry, I came into first year knowing absolutely zero code. And it was fine enough, really. Like they do teach you from scratch here, which is very nice of them. CSS, yes. Okay, that's interesting. Good to know. Yeah, sorry if I went a bit fast in the beginning, guys. I definitely should have had chat open. So yeah. Okay, it's cool though. Oh, is there an issue in the chat? Oh yeah, capitalize your Booleans. That is that. Yeah. Okay, so I'm hoping everyone's back from break. And we're good to go. I think. I mean, not many problems in the chat, so. Okay, I was gonna make an executive order decision and just kind of, what's called Booleans? Well, the person that invented it was George Boole, and he kind of did a lot of math behind this, and he wanted to flex on all of us, I guess. Interesting enough, there is a professor here, Jeffrey Hinton at the University of Toronto. He's like a really big professor in the field of AI. He's like the great blah blah blah, grandson or nephew of Boole himself, which is pretty cool. But yeah, doesn't teach anyone to be like that. But anyways, let's keep moving on to string operators. And basically, so this is kind of what we did before, where you can concatenate these strings together, and for all intents and purposes for you guys right now, just think of strings as like words, really. So hello plus world will give you hello world with horrible grammar. You can actually add a space here. It still counts. This empty space will still count as inside the word, and if you run this, then you get hello world with proper grammar. And you can also repeat this. So, hello times 3, you'll get, so this is the equivalent, obviously, multiplying by 3 is like adding, 3 of itself to each other. So, sorry. So this will give you, 3 hellos, as if you did hello plus hello plus hello with no spaces in between. Because, there's no space in this actual string. So you get hello, hello, hello. So you can kind of, do these operations with strings as well. And now, indexing. So this is actually, this string obviously has 5 characters in it, HELLO. And what you can actually do is with these square brackets, you can actually index into these words. So hello square bracket 0 will, analyze, like in Python, it's called the first element, is H here, but they start from 0 and it goes up to and not including like the last element. So in terms of numbers, so it's like 0, 1, 2, 3, 4, 5 characters in hello, but you can go from square bracket 0, which will give you H. You can go to 1, which will give you E, and 2, which is L, 3, which is also L, and 4, which is O, and 5, which will give you an out of range error. So, it starts at 0 and it goes up to and not including the last value in terms of indexing, which is, yeah, I know, and it's weird. It's honestly syntax. Like it just starts at 0. Like the 0th element is your first element in Python and in a lot of other programming languages too. It's just something to like, get used to. I mean, I didn't create Python, don't shoot the messenger. So we can also print hello -1. So -1 goes in the opposite direction. And this is also a pretty bad part, but whereas when you're going forward, you start from 0, 1, 2, 3, and 4 here. If you do negative, then it is from 1, 2, 3, 4, 5. So -1 will give you O here, like the last element. And then for this, you go from 1, 2, 3, 4, 5. You want to do negative. So like, yeah, it's very programming language specific. Python and a fair majority of like other ones would kind of go along this process. MATLAB, yeah, thank you, Sean, is a good example where it doesn't. MATLAB's a kind of a mathematical programming language kind of thing that you guys will probably run into at one point later on. Who will go negative and like these are all great questions. I have no answers for you guys because I didn't create Python. Thank you. I do try. And you can also go, like in terms of like, combination. So like going from, this is 1, but it's the second element here because it starts at 0 from the second all the way and not including the 4th element or it's 4 here, but it's really the 5th element because again, it starts at 0. So this will give you HELL. So, this is 0 and then 1, 2, 3, and up to, but not including the 4th. So yeah, bit ugly, but it's just syntax. Honestly, like I would change it if I could, but I don't think I have that authority. Let's see here. So try printing out the first 6 characters of the following string. Python rocks. So we'll give you around like 5 minutes to try to get that done. Okay, well, you know, first year NSI, that's a bit of a time. Yeah. Is this pace, you know, kind of better for you guys? Yes, no, maybe. All right, thank you, Twitch chat. Yeah, exactly. So -1 is 0, and then -2 is like, you know, L, and -3 is L, -4 is E, -5 is H. Oh, clever. You think first year's bad? Oh my God, second year's a time and a half. I mean, no, it's great. You'll all fun. Oh my, yeah, wait, 0 to 4? Wait, that's not hell, is it? Oh my God. Okay, no, never mind. Python rocks 0 to 7. Ah, well, you know, you can try to count that, right? So it's like, you know, 0 is 1, and then 2. So it goes from the 0 all the way up to and not including the 7th. So that is, am I counting right? I think that's 7 characters, which, you know what? Let's try it right now. All right, Daniel, here.
The end is not inclusive.
It's not inclusive, yeah. So, okay, let's make sure, oh my God, why can't I? Oh wait, no, that is definitely not one. I gotta manually type this out. Oh, what a pain. Let's try out what you suggested. And this will actually give out, you know, 1, 2, 3, 4, 5, 6. Look at that. Yeah, so it's 0 to 7 and not including. Yeah, there is a sneaky space in there though. If you like, we can double check that. Oh, thanks for spoiling it, but yeah, Python, because you know this space is still technically a character in this kind of like string. Okay. So have you guys, you know, any of you like finished? Yeah, 0 to 6 is better because like let's say like it was, you know, Python rocks, but like, you know, no space, right? And you do 0 to 7, then you will get, you know, wait for it, 7. Oh, we don't want that, do we? So yeah. Okay, sure. Let's just keep moving on then. But yeah, this is kind of the solution that we're looking for. And on. So the size of the string. So, you know, obviously the length of the word hello is hopefully 5. And it is. There's 5, you know, letters in the word hello. And we can actually compare these. So you can compare strings by alphabetical order. So, you know, hello less than jello is true. Because, you know, it's in the alphabet to yourself if you want, but yeah. Now, searching for a string inside a string sounds a bit odd, but you know, it's quite simple in practice. You know, you can print E in hello. So like, you know, it's E in hello. It's true. Like, you know, E is in hello. And we can also search for, you know, other things like, you know, print F not in hello. So this will print true if F is not in the word hello, which is true. There is no F in hello. And now we're going to go into conditional statements. So this is kind of a large chunk of Python does kind of like, and most programming languages use conditional statements, and they're pretty useful. And yeah, hopefully you'll see why fairly soon. So this kinds so before whenever we uncommented code and we ran it, it would always run no matter what. But sometimes we don't want that to happen. Sometimes we want to kind of limit certain outputs to certain kind of cases. And so Sherry, yeah, no, exactly. So it checks the first and the second and blah blah blah. But obviously, just think of how would you compare words that come in alphabetical order? You would check their first letters first, and then if they match, then the second and then the third, blah blah blah. So conditional statements here. So let's assign some variable var is equal to 11, and it's like English. You can check if this variable is greater than 10, we'll print this. And elif means else if the variable is less than 10 and greater than 2, then we'll print this. Else if the variable is less than or equal to 2, we'll print this. And if none of these are met, then it'll just print the variable is indeed 10. But here, these are all kind of logical conditional statements that we can try to run. And if we run this, we'll check that the variable is totally bigger than 10 because it's 11. And these conditionals help kind of limit the output to what we want it to be under very specific circumstances. So another activity, and this is kind of a long one, so we'll try to give you a bit more time, maybe 5 minutes. But create an if, elif, and else block. So kind of like what you saw here, of code that compares a string variable and check if it's between A and F, or between G and Q, or if it's between R and Y, and otherwise it's clearly Z. So a string, yeah, so just create some string variable Z, J, hello or whatnot, and with these kind of with this kind of logic, and this example here as well, I'll try to get it so that you see everything in the screen actually. Yep, there we go. So this page should be enough to kind of answer this activity. But yeah, it's a bit of a challenging one. If you don't get it, then it's fine. The answers will also be we'll slide the answers in here, and you can look at them in the recording or afterwards. But yeah, let's say we'll try to keep going at around 7:21 then. And if you got it, just just flex in the chat. That's sure. So string of one letter, multiple letters, challenge yourself, good try. I think the output should be the same either way though, because it will check, the first letter and whatnot. Yeah. Yeah, definitely. If you guys need more one-on-one help, just let any of us know, and we'll try to shoot you to a breakout room. Well, you can just do the actual. Let's say you declare a variable with a string hello. You can just do if var is between A and F. Yeah, your logic is pretty much correct. But you can actually, instead of just not just the first letter, you can just slide the entire word in there if you want. Yeah, it'll check, I believe, the first letter of that word, either way. Just kind of how, this ran, hello and jello. Yep. Oh, okay, sure, yeah. Sneak peek, I guess. So this is kind of okay, let's just try to quickly get this over here. So this is kind of what we had in mind for the first bit. So you can declare some variable hello, and if var is greater than equal to A and less than or equal to F, if it's between A and F, then print between A and F. And it works even with this entire kind of word, as I kind of predicted, I guess. But, well, A less than equal to var less than equal to F does not work. Well, let's give it a try. And after this, I'll just kind of like show the answer to you guys. And okay, we're all right. Save me time. But I'm kind of curious too. Actually, not gonna lie. Well, there's no error here, so like, it should be fine. Okay, so it's 7:21, so I'll just, paste the answer and kind of try to explain it. By the way, what I said before, there's no error, so it's probably correct. That is not a good philosophy to have in general, but like, yeah. For the sake of time, I'm going to assume it's correct. And there seems to be evidence. So, but yeah, so this basically, you get a variable hello, and you check if it's greater than A and less than F. So if it's in between A and F in the alphabet, and this kind of repeats, this logic repeats until you finally conclude that it has to start with C, because all the other letters are exhausted. So H should be between G and Q, and sing the alphabet to yourself, and you'll find that that's true. So moving on. So this is kind of where I talked about where, there are some, further uses of like the stuff we've seen before. We're trying to like, progress so that, they do kind of like stack on top of each other. But this is an introduction to loops. So loops are a very useful and very powerful kind of, tool to use in pretty much any coding language, programming language. And it allows you to execute a statement or a group of them, multiple times over without without like hard coding it, And there's two types of loops, for loops and while loops. And so for loops are kind of like, you can define the parameters to be a lot of things. First of all, like lists. So, comment this. So then, when we do for something in something, like this can be whatever you want it to name it. This could be like for E, like for X, but, it usually makes sense to like, make it a variable that like, makes sense in the context of the actual problem. So, for animal in this list, which is, dog, cat, and mouse, we'll print animal, comma, is a mammal. So animal. So this variable will go over each individual element of whatever is here. So after this in statement in the for loop, and we can just do operations on it within the for loop. So if we print this out, we'll get dog is a mammal, cat is a mammal, and mouse is a mammal, which are all true. So yeah. And whereas range can return an iterable number from 0 to the given number. So this will make a bit more sense once we run it. Sorry. But for I, again, any variable works. But here it's for I in range 4, print I. So if there's no initial number declared, it's gonna be assumed to be 0. So it's gonna be like for I in range 0 to 4, and we print I every time. So this should print 0, 1, 2, 3. And again, it goes up to, but not including that last one for Python. It depends on the programming language, but that is the case for a fair bit of them. So, and so again here, so with range, you can define a lower limit and an upper limit. So instead of going from 0 to whatever number is in there, you can actually go from, this lower number to whatever high number and kind of print from there. So, from 4 to 8, not inclusive of the final one. So it should be 4, 5, 6, 7. And this is kind of the last iteration of it, where you can do, you can define a lower, upper, and a step kind of condition, where it would actually, here it's going from 4 to 8 with like, step size of 1. So 4, 5, 6, 7, but you can declare like a different step size. Like, I want to, go to like, from the lower to the upper bound at a rate of, 2 numbers, per step, or like 4, or, in this case we do 2. So, and if you don't declare, the default value is 1, as you've seen from, these prior examples. But if we declare it to be 2 instead of 4, 5, 6, 7, we should expect 4 and 6. Just, yeah, there we go. Oh, sorry, let me just comment this out real quick. But yeah, so this should give you like 4 to 6. And again, not 8, because Python doesn't like including the last element. So. So this would be like a quick, activity. Try to create a for loop statement that goes from 25 to 50. So the lower bound being 25, the upper bound being 50, with a step size of 5. And just for a little added trick, I guess, we print that value out, multiply by 2. And again, this has to be within the for loop, as we've seen from these other examples. So we'll give you 2 minutes to do that. We'll move on at 7:27. I'll just put the answer in here. Feels so weird not having like verbal feedback, because normally that's like kind of how this works, but index value, you're printing out the actual index of whatever you define. So you're going from 25 to 50 with a step size of 5. So you're going to be printing out ideally 25, 30, 35, 40, 45. And what we want you to do with each of those calls is to actually print that index value out, but multiply it by 2 and print it out in the for loop. Okay, so it's 7:27. So I'll just kind of put the answer here. Oh, values of I automatically integers because integers. Yeah. And 2 over this thing is 2i. I don't think so. No. But we can test that out actually right now. No, actually, no, I don't think that's not going to work. No. Let's see here. Yeah, invalid syntax. Yeah, that's probably should get it. So here. So yeah, it's kind of like going through like the activity. For I in range, we define the lower bound as 25, upper as 5, and we step through it, in steps of 5, and we'll just print out whatever I is multiplied by 2. So we'll get 50, 60, 70, 80, 90. That's that. And we can also loop over a list and retrieve both the index and the value of each item in the list. So what that means is, this list obviously has values, dog, cat, and mouse, but you can also index them. So, animals, square bracket 0 will give you dog, square bracket 1 will give you cat, square bracket 2 will give you mouse. And sometimes, I guess like for an example that I used more recently for like, stuff like machine learning, you would want, like the index value and the actual value itself in the list at the same time. And a way to do that in Python is to, instead of just doing, for I in this list, do for I comma value in enumerate animals. And if you print these both out, then you'll get, it doesn't include 50 because remember, Python doesn't go, it's up to, but not including the last value. So it doesn't include 50, it'll include 45. So if we run this, then we get 0 dog, 1 cat, and 2 mouse, because dog is in the 0th index, cat is in the 1st index, and mouse is in the 2nd. Again, Python starts indexing from 0. It's weird, but I mean, I didn't create it. And so these are all been for loops, but now we can do while loops. And while loops are a bit dangerous, as we might get into later. But basically, this while loop can execute a set of statements as long as some condition is true. So if you mess up the condition, you might run into like an infinite while loop, which is a very common problem. But this might make more sense. So count starts at 0, and we have this loop. While count is less than 3, we print the value of count, or the count is, and we print the value of count, and then we raise the value of count by 1. So eventually it'll be like count starts at 0, goes here, it's still 0. Add 1, so now count is 1, and it goes back to the beginning of this while loop, not to like the beginning of the file, but to the beginning of the while loop. Does it again? It sees that count is 1, adds 1, and now it's 2. It goes here, checks, count is still less than 3, it's 2. Print, now count is 3, and now count is 3, and it's 3 is not less than 3, so it breaks this while loop, and it goes to the last thing, which is print goodbye. So here the count is 0, 1, 2, and goodbye. what is it? Yeah, so enumerate, it's rather than just giving the index or just the value, it gives both. It gives you access to both. So you can print, for I, comma, value in enumerate. So think of this as, I being the index and value being the value. And again, you can name these whatever variable names you want, but this is just to make sense in the current context. Like this is actually the index and this is actually the value. If you use range, well, if you just use range by itself, then yeah, you get values. But if you want to, go inside of a list, you should do like, for I in list usually, like as we see here, like for animal in this list, if you print, the animal just becomes, dog, cat, mouse. But you get the values iterated, but you don't get the actual index. So like, you want the index sometimes too. No, absolutely not. Let's see. So quick activity again, probably a 2-minute one. Create a while loop that adds up the first 10 natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Store it to some variable. There's a lot of I plus equal ones, but I miss. Oh, yeah. That's a different programming language, but no I plus plus. No. That's like C. It was one of those C's, I think. Maybe all of them. Aha, I do remember first year coding. Okay, that's great. Yeah, so in about a minute, I'll just, paste in the answer for this activity and we can just keep going forward. Okay, so I'll just this. So let's have a look at this real quick. So we start with n is equal to 10, and we initiate, like the sum and counter variable. So sum is 0 and I is 1. And while I is less than or equal to n, we can do sum is equal to sum plus I itself, and I is equal to I plus 1. So I add 1 to I, the old value of I, and this will keep looping as long as n is greater than or equal to I. So I will go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it will break at 10. But all the while, sum is being added by the value of I. So this loop should give the sum is 55, which, yeah, it sounds about right. So moving on. So loop control statement. So, if you want to break out of a loop, because, you might not want to, go through the entire loop and it's, to its completion, you might want to break out early if you hit like a certain condition, or you hit like, some sort of like desired result, you may want to break out of a loop. So this is where you can combine some, stuff we saw before, like an if statement. So, for letter and hello, and if the letter you're on, and your letter will just go through this actual string. If letter is equal to L, then you break. Else, the current letter is whatever the current letter is, and it keeps going. So it goes from H, E, and then wait, letter is equal to L, and that satisfies this conditional, as we saw before, if, and then it breaks out of the loop, so it stops. So yeah, again, this is pretty useful for like finding and then stopping at certain letters or values within like a list or string or collection or what have you. Whereas the continue statement just ends the current iteration in its entirety and just moves on to the next iteration. So, for example, for each letter in hello, if the letter is equal to L, then you just continue. Also, you just print the current letter is this letter. So you get H, E, and then once you hit L, you don't even print. You just continue to the next iteration. So H, E, and then you skip the 2 L's, then you just go to O. Oh yeah, once it hits 8 p.m., guys, like you're not obligated to stay here if you don't want, if you're busy. Feel free to leave. Like this stuff will be provided after, so don't worry too much about that. So moving on to lists. So these are kind of like, lists are like, collections of things that can, store, anything really, numbers, strings, even other lists, and you can create an empty list. So, list one, just go to this. So this is just like, this is how you declare a list element or list, variable instance. And you can either declare one that's empty, or what you can do is declare a list that's already filled. So, like a pre-filled list of certain values. So actually, the same thing. We can print list one. Let's show you what's in list one. So look, it's nothing. It's absolutely nothing. In list two, 4, 5, 6. So keep that in mind. And also, we can add stuff to lists. It's not as simple as adding like integers or strings. You gotta do this thing called list.append. For English, append is just appending stuff. So list.append. So this dot is also important. And then in curly, in round brackets, 1. So if you do that and we print off the resulting list, it's not an empty list anymore. It actually has 1 in it. And you can append 2, and we'll just keep doing this and just see the result. So append 1, 2, 4. So this list is now 1, and then we added 2, and then we added a 4 to it. So, and then you can also remove stuff from a list with a pop. So appending and then popping. So if you pop, oh my god. We just do dot pop with round brackets, and you just pop out something in it. So you pop out the thing that's like the last thing you added. So it's like kind of like think of like a stack of pancakes you're adding on when you append, and when you pop it, you're taking off like the most recent pancake from the stack. So, and we can put it back if we want, or just one, I guess. So it's 1, 2, 4, and we popped out the 4, and then we reappended the 4 in. So and lists you can access like kind of like any other array, with Python starting at 0 and going to the size of the array, like as we saw before. Python loves to start at 0 being the first element, and it goes up to but not including the last element in terms of size of whatever collection you're working with. So here, the 0th element or the first element of list 1 is 1, as you can see here. And likewise, we can look at the last element either by doing since this is of length 3, we can just do like list and then square bracket 2, or here just do -1. You get 4 as well. And if you look outside the boundaries, like although there's 3 elements in this list, you can only go up to 2 because it's 0, 1, 2. But if you go and you try to index into 3, then you get an out of range error, which is always fun. And this, you can also look at multiple values in a list with the slice syntax, kind of as we saw before with some of the strings. But you can go from the first all the way to the last, but not including the last element. Here going from the last element, and then this colon here is from this like value, like this, like the third value all the way up to the last is what you mean by this colon. And this colon in the beginning is everything from the beginning all the way up to and not including this element. And again, if you do like double colons, then you can actually select every second entry. And here you can do like double colon -1, which actually returns a list in reverse order. So a lot of little syntactical kind of like tricks with Python. Not all of them strictly necessary, but fun to know. So yeah, again, so for this one in particular, like 0 to 2, you go from the first element, the second, and then you don't include the last element. That's Python loves doing that. And then here you go from like the last one to whatever's next, which is nothing. So just the last element, that's it. And then it's kind of like going on with like this logic, and you see the comments here as well. Can you select every second entry in reverse? Probably. I'm guessing with -2. Let's hope I don't get exposed here. Yeah, total, -2. Yeah. Okay. So yeah, you can use any combination of these steps, start, end, and step. So, another good thing to know with lists. But lists are also mutable, which means that you can change the value stored in them. So basically, let's say you declare, okay, we can comment all this out actually. It's good because it's taking up some space. But yeah, so let's say you have a list with 0, 1, 2, 3, 4, and you can duplicate a list, but this is one of those things that's like, very kind of like confusing for like, oh no. Where'd the chat go? Well, like this is kind of confusing for like, a lot of people, but basically like as to why. But when you copy a list onto another variable, let's like list 2 is equal to list 1. If you change list 2, you also change list 1. And that's not great. So look, so you can go from the 0, 1, 2, 3, 4. You make list 2 equal to list 1. So list 2 is now also 0, 1, 2, 3, 4. But now we're changing the third element in list 2 to equal 5. But if you print list 1 and list 2, they both have changed. So we don't always want that. We rarely do actually. But in order to kind of avoid that, when we duplicate a list, be sure to include this line as well. Like list 2 is equal to list 1. And this way, this kind of like prevents you from like copying from the original. It's very weird, but honestly, it's just, again, I didn't create Python, guys, I'm sorry. But another quick activity, almost there, guys. But try to create an empty list and then create a loop that appends the first 10 numbers into the list. So it should look like, 1, 2, 3, 4, you guys know what the first 10 numbers are. So we'll give you like maybe 3 minutes for this one up until 7:45, and then we'll try to move on. See if I can try to get chat back up. There it is. All right, one sec, guys. I'm gonna grab a glass of water. I have not drank in a hot minute. Yep. Okay. Sorry about that, y'all. I was very thirsty. That wasn't the word to use. Let's see. Yeah. So going back to this activity. Can you do list range? Yeah. So that's kind of what we did here in a way where you go For I in range 1 to 11, we just append whatever I is to this empty list. So 1, 2, 3, 4, blah, blah, all the way up to, but not including 11. So this will go up to 10. Yeah, and yeah, we can. Oh yeah, so I guess just to like let's look at Sean's little solution here actually. So sum list equals, so we do range 1, 11 equals this. Oh wait, I think it has to be like this. Oh wait. Oops. Yeah, that looks about right. Yeah, so this is like another way you can do it, but yeah. So moving on. Engineering better than CS. Oh, okay, let's try to keep in mind our lovely CSSU members here. Oh my God. So introduction to collections. Let's go to tuples. So tuples are basically a collection of data that's ordered and immutable. So you cannot change what's inside of a tuple. If you want to create a tuple, simple. Just use round brackets instead of square brackets. So you can use a tuple. You can create a tuple where it's physics, chemistry, 1997, 2000. Because why not? Another tuple, 55, 50, an empty tuple. Print the tuple out. Then we get this. So we use round brackets on square brackets. And if you want to access tuple values, same as a list. Just square bracket and whatever index you want. So we can get, if it's physics, chemistry, 1997, 2000, if you want the first element of this first tuple, that's physics. And for this second tuple where it's 1, 2, 3, 4, 5, if you want the second all the way but not including the last, then we get all the way including the last for 2, 3, 4, 5. Yeah, because it's 5, it's not like 4. So it goes over. So yeah, so it goes up to but not including the fifth. So lists you can edit and change what tuples are set. Yes, so yeah, exactly. But you can't add to tuples. You can add tuples to each other, which we'll see later on. But yeah, so again, it's just as you said, individual types cannot be changed. Inside these tuples. So if you try to change, the first element of a tuple into 100 instead of 1, you get slapped with an error, which is always fun. And if you want to change tuples, you can actually add to them together to create a completely new tuple. So remember, tuple 1 was physics, chemistry, 1997 and 2000, and tuple 2 was just 1, 2, 3, 4, 5. And if you add these together, yeah, you get this. I know a lot of these things are executing instantly, so you might be wondering like, oh, what do you mean by fast? No, trust me, once you write like a lot more Python, these things take forever to compile. But yeah, so these are kind of faster. But so individual values inside a tuple can't be deleted. Can't change those individual values itself, but the entire tuple can be. Yeah, if not, then how would you ever get rid of it, really? But yeah, so like yeah, so you can't print tup4 at 1 because it's not defined because it's deleted. And there are more collections such as dictionaries, which are let's see here. So these are basically kind of like unordered but changeable indexed keys and value pairs. So let's make a bit more sense. So instead of round or square, you use curly brackets. So there's a dictionary, and in the dictionary you will define the brand in the dictionary as that of Ford, the model being a Mustang, and the year being 1964. So if we actually, for example, if you want to print the the brand key in this dictionary, then we should get the value of it, which is the Ford. Okay, let me just comment this out real quick. But yeah, we get the Ford for the brand. And if you want to do like, let's go, what's the model of this actual dictionary? And we should get the Mustang. So yeah. Dictionaries are, it's kind of like, a dictionary in real life, just think about it like that. Like there's a word and there's like a certain like, value for that. And you can just, pair them off all neatly. And kind of last topic is an intro to functions. And these are kind of like, for the workshop number 1, these are kind of like, the culmination of everything we've learned so far. But a function is basically a block of code which only runs when it's called. So, rather than, if you uncomment any of these and you run the actual file, this will run. Then in this case for functions, like if we just uncomment this, define my function and print hello, if you just run this, nothing will print. But if we call the function, and the way we call functions and the way we define them actually is you define them, def to define a function, and any name, open bracket, close bracket, and then colon, and then you index accordingly, and you can just write whatever you want in the function. And if you want to actually call it, then you just call the name of it, my function, same kind of syntax here, and now we should get hello. So that's a very basic function, but there's a lot of other things you can do with them. So you can pass in data known as parameters into a function. So rather than just like some empty like function that has nothing else you can call on top of it, you can actually put in parameters, define, function, my name, and then the parameter is called name. You can name it whatever you want, but the cool thing is once you define like the name of your parameters here, you can use them inside the function. Like it's kind of like an isolated, environment where you can use this, name parameter. So, print hello plus whatever name is. So these two names are like the same. So be careful not to use like, like name or like whatever, parameter you put here kind of unnecessarily. So that's why it's not really recommended. So if you can do like a for loop, like for I in something, if you do like define my name and then I here, like you're in for a whole world of pain. So just don't. So be mindful of that. But yeah, so name here can be used inside the function, and we're using it here to, add on top of the hello message. So here we pass in my name and then, Bob. So we should say hello, Bob. Yep, hello, Bob. We go over global and local variables. Briefly at the end, just briefly. So functions can also return data. So right now we've only been printing data, but we can actually return data, and this helps like, this can actually be assigned to like, other variables when you call the function, or just like, you can print them out themselves by themselves. So, so here we're defining my function with, some parameter x, and instead of printing, we're returning 5 times x. So now we can print out, the reason we're using print here and, not here is because we're not printing anything in this function. We're actually returning the value. So we want to print whatever value this, function instantiation actually like returns. So for the first one, it'll return 5 times 3 times 5, 5 times 9. And if you're forced to learn your timetables like me, then you'll remember it's 15, 25, and 45. So that's great. And another quick activity, try to create a function that takes an integer input and finds the sum of all the numbers between 0 and whatever input you put in. So, like this being some input that you put in. So, for example, if the input is 3, then the function returns 1 plus 2 plus 3. And we'll give you like around 3 minutes for this one. 3 minutes for this one, because we're almost done anyways. if anyone's completed the activity, just kind of feel free to say so in the chat, I guess. Oh my God, imagine using Microsoft Edge. Okay. Okay, I'm gonna put in the answer to this activity right now, actually. And oh, this is our last activity, you know. Try to hold in the tears, I guess. So this is our, again, you know, lots of ways of getting the right answer. This is just one of the ways that we kind of come up with, where we would define some function, my function, with the input parameter x, and you know, we'll have the sum is equal to 0. And for I in range from 1 all the way to x plus 1, because again, you know, like Python for some reason loves to go up to but not including the last value. So x plus 1, and then sum is equal to plus equal I. Again, this is just shorthand for sum is equal to sum plus I. And in the end, we return sum. So if we print, for example, my functions in 5, should get 15. So is that right? Yeah, that's right. And this is kind of the last topic, and you know, this is kind of going over like, you know, the whole global variable thing, where there's a good point actually, where functions can't change the value of like, you know, stuff outside of the function stuff. Again, it's like a kind of like an isolated environment. You know, this isn't C, it's like Python. But there is one way to get that, where you can declare global variables. So I'll give you an example. So let's say you start with a define some function sum with arguments 1 and 2, and we do total is equal to argument 1 plus argument 2. And just to make it clear, we'll print out the statement inside the function, total is equal to whatever total is in the function. But here we're declaring total is equal to 0. And we're going to sum 10 and 20, and we're going to print the function, like outside the function, total is equal to some value. So look at this. Inside the function, it's equal to 30, because, you know, total is just, you know, defined to be equal to argument 1 plus argument 2. But outside, since we declared total is equal to 0 here, and we're just calling the function here, it's still equal to 0. It doesn't change, you know, variable values outside of it. However, if we start off with global total, this declares total as being like a global variable, which can be changed inside of a function. So now if we run this function, we get 30, 30. So, and you know, there are like there's you know, other programming languages have other ways of, you know, managing this, and you know, I'm sure you guys will get into it in the years to come. Or there's also another workshop coming up for C, which we'll probably get into that as well if you want to hop on for that. But yeah, that is it for today. So thank you all for joining the first workshop in this series. There's, you know, a part 2 for Python coming on September 22nd. And like an intro to C coming early on in October, if you guys want to drop by for that. Okay, the part 2 is on the September 29th. And yeah, so I'll turn it over to Moji for now.
Hi again, everyone. Thank you so much for joining, and thank you, Chan. That was definitely a very full 2 hours of learning. And there were a lot of stuff, and we're very happy that a lot of people actually showed up, and so happy that all of you guys stayed throughout. You have one of 40 people staying throughout the whole thing, so that is fantastic. If you guys have any questions, write them in the chat right now before we finish the session, or you can also reach out to us at uoft@IEEE.org. The next series of the workshop will be on September 29th. Sorry. Will be on September 29th, and it would include our Python Advanced And definitely go to that one if you want to hear some more cool things about Python and learn more. And just to let you know, keep an eye out on our IEEE website. You can check out our other socials and other workshops. If you want to stay updated and enjoy this workshop, we definitely want to see you guys there. And also, if you want to see the recordings or the Python files and the slides, don't worry, they will all be sent out at the email after this session, and they will be sent out either tonight or tomorrow morning. Hope you all had a great time here, and thank you guys, and we'll see you guys later.